Hi everyone, welcome back to the channel. Let's start paper 4 of A-level chemistry, October-November 2025, variance 41. We have done variance 42 before. So let's talk about variance 41 in this session. So question number 1, solutions of group 2 hydrogen carbonates, generally represented by this formula, decomposes on heating to give corresponding metal carbonate, carbon dioxide and water. Write an equation for the decomposition of strontium hydrogen carbonate. Okay, so strontium hydrogen carbonate, when decomposed on heating, it will turn to strontium carbonate, then carbon dioxide, and then water. Okay, it's a balanced chemical equation, by the way. Now the next part is thermal stability of group 2 carbonates increases down the group. Explain this trend. Um, Down the group, ionic radius increases. So charge density and polarization decreases. That means cation cannot distort the electrons of carbonate ion easily. So more temperature is needed for thermal decomposition. Okay. And therefore thermal stability down the group increases. The hydroxides and fluorides of group 2 elements show similar trend in solubility. By the way, the group 2 hydroxides solubility always increases down the trend. Similarly, the fluorides of group 2 elements solubility also increases down the trend. So describe the trend in the solubility of fluorides of calcium, strontium, and barium. Explain your answer. So least soluble is basically calcium. Then we have strontium fluoride, and most soluble is barium fluoride. Okay. Explanation. The group 2 solubility of group 2 hydroxides can be explained on the basis of lattice energy and hydration enthalpy, and both of them are exothermic and depends on charge density. All right. So we have done all these in theory classes. So let me write the explanation in this regard. Mm, Down the group, I don't know what's happening with this. Ionic radius increases. So charge density decreases. If charge density decreases, then lattice energy and hydration enthalpy both decreases. In this scenario, lattice energy play a key role, which is why lattice energy decreases more significantly than hydration enthalpy. So standard enthalpy change of solution becomes exothermic, and therefore solubility increases. Okay, now let's move on to the next page. Define enthalpy change of hydration. Enthalpy change occur when 1 mole of gaseous ions are dissolved in water to give an infinite dilute solution. All right. State the main factor that affects the magnitude of enthalpy change of hydration. Explain your answer. Well, hydration enthalpy depends on charge density, and charge density depends on charge of the ion and size of the ion, right? So hydration enthalpy is directly proportional to the charges of the ion and inversely proportional to the size of the ion. So hydration enthalpy depends on charge of the ion and size of the ion. So the greater the charge, the greater the magnitude of charge, the stronger the electrostatic attraction between iron and water. Okay. The higher the ionic radius, the weaker the electrostatic attraction. Between iron and water. Okay. So technically, there are two main factors: charge and ionic radius. And charge and ionic radius, also we can say charge density. The higher the charge density, the higher the hydration enthalpy. The lower the charge density, the lower the hydration enthalpy. Okay. You can write the answer of this particular part in that way also. Now, in the next part, table 1.1 shows various energy changes. Lattice energy is given, hydration of cation is given, hydration of anion is given. Examiner is looking for the enthalpy change of solution of magnesium fluoride. Helpful to draw a labeled energy cycle, show your working. So, I've told you in the class that first of all, we need to make standard enthalpy change of solution in which 1 mole of ionic solid is dissolved in large amount of water to give aqueous cation. Oh, that's fluoride. I don't know what's going on with this fluoride. I don't know what's going on with this. Let me handle. There might be an error in the app, most likely, which is why it's not even working properly. That's the whole issue. Yeah. This is magnesium fluoride. Solid dissolved in large amount of water to give aqueous cation and aqueous anion. And that's standard enthalpy change of solution. Okay. Now, hydration of cation and anion and lattice energy is given. So, what's lattice energy is? When gaseous cation and gaseous anion combine together to give 1 mole of ionic solid, that's called lattice energy. And when gaseous cation and anion is dissolved in water, it will turn to aqueous cation and anion. That's going to be your hydration enthalpy. Okay. On the basis of this entire thermochemical Hausdorff cycle, we have deduced one expression And that expression was standard enthalpy change of solution equals to minus lattice energy plus hydration. Lattice energy की value is given minus 2957. Hydration of cation and anion both given. The hydration of cation is minus 1926 plus the hydration of anion is given minus 505. And obviously we have two fluoride ions, so we need to multiply this value by 2. So by using this entire values, I'm going to get the 505 times 2 minus 1010 plus 2957 minus 1926 2936. Okay, so it's going to be minus 2957. It's basically plus 21 kilojoules per mole. Okay, so plus 21 kilojoules per mole is the right answer. Okay, that's the first question. It is quite lengthy. Let's move on to the next part. Mercury 1 fluoride Ag2F2 is slightly soluble in water. If it is slightly soluble in water, then it means we need to make an equation here first. This is Ag2F2 ionizes slowly and reversibly into its 2 Hg plus 1 plus 2 fluoride ions. Okay. The cation Ag2F2 exists as the diatomic ion with a covalent bond. Okay, that's surprising by the way. Write the expression for the solubility product of including the units. So Ksp is basically concentration of oh oh my bad. Um, it's basically Ag2 plus. No, that's the cation. We need to write Ag2 plus. Okay, plus 2 fluoride ions. That's a crucial information. You need to mention this cation here. Okay. So concentration of Ag2 plus, concentration of fluoride ions. Since we have 2 moles in the formula in the equation, we need to it has to be in the number of moles. It has to be in the power because we have 2 moles in the equation. Unit. This is going to be mole per dm3 into. This is going to be mole square dm minus 6. So unit is going to be mole cube dm minus 9. Okay. The solubility of this compound is given in mole per dm cube. Calculate the value of Ksp. That's an easy thing. See, guys, Ag2F2 and Ag2 two positive ions exist in 1:1 ratio according to the equation. When we have 9.20 into 10 to the power minus 3 mole per dm cube, which is also called molar. So concentration of Hg2 2 plus is going to be same, which is 9.20 into 10 to the power minus 3 mole per dm cube. So there's the first step of this particular part. In the second step, Hg2F2 and fluoride ions exist in 1:2 ratio according to the equation. When we have 9.20 into 10 to the power minus 3 molar, molar means mole per dm cube. That's a unit of concentration, guys. So the concentration of fluoride ions is going to be how much from here? 9.2 exponent minus 3 into 2. So it's going to be 0.0184 mole per dm cube. Now let's plug in these two values in the KSP expression to get the value of KSP. Concentration of Hg2 2 plus is 9.20 into 10 to the power minus 3, and the concentration of fluoride ion is 0.0184 power square because we have 2 moles in the equation. Okay. So 0.0184 square is going to be this into 9.2 exponent minus 3. So it's going to be 3.11 into 10 to the power minus 6. So the value of KSP is 3.11 into 10 to the power minus 6. And that's the end of first question. I hope it makes sense to you. Next question. Iron is a transition element, can form a stable ion of +2 and +3 oxidation state. Explain why transition elements have variable oxidation state. Transition elements have variable oxidation state because of the availability of electrons both in 4s and 3d orbital. Electrons are available both in 3d and 4s orbital. And these orbitals have a close energy gap between them. Also, there is a close proximity of energy of 3d and 4s orbital. Okay. Next part. Aqueous solution of iron 2 salts contain complex ions. Define complex ion. An ion which is formed when a ligand. No, no, that's not a correct definition. An ion in which a dative bond is formed. Dative bond is also called coordinate covalent bond between ligand and transition metal ion. All right. Now the next part is aqueous iron 2 ions can be converted into this complex. Suggest a suitable reagent for this conversion and type of reaction. So reagent is going to be sodium hydroxide. Formation of this compound indicate that iron 2 ions or aqueous iron 2 ions needs to react with NaOH. And for this particular reaction, we can say it's a precipitation reaction or also called acid-base reaction. Okay. So acid-base or precipitation, both are acceptable. Let me give you an equation here. This is FeH2O taken 6, 2 plus. So obviously I'm going to use few drops of sodium hydroxide. So I'm writing 2 OH negative ions. An acid-base reaction takes place. The complex compound is formed along with 2 moles of water. That was the concept we have given you for copper. So मैंने बिल्कुल exactly iron के लिए भी same concept use किया. ठीक है? Now this complex ion is a green precipitate. By the way, this complex can also be written in this way. Okay, so technically it is iron 2 hydroxide, and iron 2 hydroxide is a green precipitate. Okay, that turns brown on standing in air, and air contain oxygen. Remember that. And I think मैंने ये चीज डिस्कस की आपके साथ क्लास में. We have discussed this scenario in the class. Not with respect to these electrode potentials, but with respect to the explanation or concept. ठीक है? The two electrode potentials for some electrode reactions are given. Okay. Use this information in table 2.1 to explain why this turns brown on standing in air. Include an equation for this reaction. So first of all, let me write the equation. Since this half cell has a more positive recipe value, so I'm going to write it down as it is. So oxygen plus 2H2O plus 4 electron, reversible sign, 4 OH negative. So this reduction equation will remain as it is. And in order to write in oxidation form, I need to flip this equation. So when I'm going to flip this equation, the equation is going to be like this. Fe H2O taken 4, OH taken 2, plus OH negative ions, reversible sign, Fe H2O taken 3, OH taken 3, plus H2O plus electron. Okay. So first of all, we need to balance the number of electrons so that we can cancel them out. And for that, इस equation को हम multiply by 4 करेंगे. As soon as the number of electrons are balanced, they will cancel out with each other. And obviously these 2 moles of water are going to cancel out with 4 moles of water. These 4 OH negative ions cancel out with 4 OH negative ions. So the final equation is going to be like this. 4 FeH2O taken 4, OH taken 2, plus O2 arrow 4 FeH2O taken 3, OH taken 3, plus 2 moles of water left. Okay, that's the equation, final equation. So I'm done with this equation. So that is the first part of this answer. So I'll get 1 mark for this overall equation. Okay, still we need to determine the remaining 2 marks. So air contain oxygen, so it will oxidize iron 2 ions into iron 3 ions. Okay. Um, when we have got the equation, overall equation, we need to determine the overall cell potential value. So it's going to be E naught right minus E naught left. E naught right means reduction potential. E naught left means oxidation potential. So E naught right basically the more positive SCP value, and E naught left is basically the negative or less positive value. In this case, we have a negative value, so I'm going to plug in the value in the formula, and the answer is going to be plus 0.96 volt. Okay. तो एग्जामिनर यहाँ पर नहीं कह रहा कि ई नॉट सेल निकालो, बट जब हम ओवरऑल इक्वेशन डिटरमिन करते हैं तो हमें ओवरऑल सेल पोटेंशियल वैल्यू भी डिटरमिन करनी होती है. दैट्स व्हाट आई हैव टोल्ड यू इन द क्लास ड्यूरिंग द लेक्चर. ओके, सो यू नीड टू कीप दैट इन माइंड to get the third mark in this specific part of the question. Let's move on to the next page. The complex cobalt 2 ion reacts with hydrogen peroxide as shown. Okay. Calculate the delta G naught in kilojoules per mole for reaction 1. First of all, let me give you an explanation here. First of all, let me take out the number of moles of electrons. This is cobalt 2 ions. It is converting into cobalt 3 ions and electrons. Okay. And H2O2 is converting into hydroxide ions. So how many hydrogen atoms here? 2. How many oxygen atoms? 2. So we need to put 2 here. So I believe it will absorb 2 electrons. So here we have 2 minus charge. Here we have 2 minus charge. So charge is balanced on both the sides. We have 2 hydrogen. We have 2 hydrogen here. We have 2 oxygen. We have 2 oxygen here. So I need to multiply this equation by 2 so that number of electrons can be balanced. As soon as the number of electrons are balanced, we need to cancel them out, and so we'll get the final equation which is already given in the question. Okay, and that is the final equation जिसकी एग्जामिनर ने हमें इंफॉर्मेशन दी. आई होप इट मेक सेंस टू यू. आपको पता चला हो कि ये कैसे आया है हमारे पास. What is the background of this overall equation? Okay, so that's the overall equation. So 2 electrons are lost and 2 electrons are basically gain हो रहे हैं, which is why the value of n is going to be 2. Let me write down the delta G naught expression. Delta G naught equals to minus NF E naught cell minus 2. The value of n is 96500. It's given in the constant table at the end of this paper. E naught cell is value is given, which is 1.67. So delta G naught is basically minus 322, 310 joules, mole inverse, Kelvin inverse. Basically, this 1.67 volt equals to 1.67 joules. So answer has to be in joules, right? We need to convert them into kilojoules because Gibbs free energy is always written in kilojoules per mole, so it's going to be minus 322.3 kilojoules per mole. Oh, yeah. Okay. No, not Kelvin. There is no temperature here. मोल से मोल कैंसिल, कूलम से कूलम कैंसिल, मोल, जूल per mole. Yeah. Okay, I hope it makes sense to you. So that's the answer, guys. Minus 322.3. Question number 3. Solid manganese 4 oxide catalyzes the decomposition of hydrogen peroxide. State the type of catalyst for this reaction. Since this catalyst exists in solid state and reactant exists in aqueous state, which means both of them have different physical state, which means it is an example of heterogeneous catalyst. because because examiner is looking for the explanation also. So मैंने स्टेट कर दिया है that it is a heterogeneous catalyst. एक्सप्लेन कर रहा हूँ because reactants exist in aqueous state while catalyst exist in solid state. Which means both of them exist in different physical state. Hydrogen peroxide reacts with iodide ion in acidic condition as shown. Okay. The initial rate of this reaction is investigated with different concentration of these reactants. The result obtained are shown in table. Use this information to deduce the rate equation for this reaction. Explain your reasoning. To get the rate equation, we need to determine the individual order of each and every reactants. So let me give you an example for iodide ion first. See, in iodide ion, concentration is doubled, initial rate is also doubled, while these two reactants remains constant, which means with respect to iodide, it is first order reaction. So in experiment 2 and 3, concentration is doubled, so initial rate is also doubled. Hence, first order. Okay. Now the next is for hydrogen ion. Look, the initial concentration of hydrogen ion will remain same, while here the initial rate will remain same. So if concentration will remain same and initial rate will remain same, which means there will be no change in the concentration in the initial rate, and therefore with respect to hydrogen ion it is zero order reaction. अब second और third experiment में देख लीजिए, इसमें concentration जो है वो same है लेकिन initial rate change हो रहा है. इसका मतलब this initial rate doesn't depend on the concentration of hydrogen ion, and therefore with respect to hydrogen ion it is zero order reaction. So for experiment 2 and 3, concentration remains same, but initial rate changes That means rate doesn't depend on the concentration of hydrogen ion. Hence, it is zero order. In experiment in 2 and 3, the concentration of H2O will remain same and the concentration of this becomes twice. So 2 and 3. Now last for the least, for H2O2, see, concentration of iodide ions are twice. Hydrogen ion will remain same, rate will remain same, and this concentration is going to be half, which means with respect to H2O2, it is first order reaction. My goodness, that's tricky. In experiment 1 and 2, concentration of iodide ions are doubled. No change. Concentration of H2O2 becomes half. While concentration of hydrogen ion and rate will remain same. And rate will remain same. Hence, it is first order. So H2O2, oh my goodness. So I need to deduce the rate equation since I'm running out of space. So let me write it here. Rate equals to K concentration of H2O2 because it is first order reaction. So it has to be in the rate equation. Concentration of iodide ion is also first order. So it has to be in the rate equation. Since hydrogen ion has a zero order reaction, so we don't need to mention zero order reaction in the rate equation. So that is going to be the rate equation for this particular reaction. Okay. I hope it makes sense to you. Okay. Use your rate equation from B1 and the data from experiment 1 to calculate the rate constant for this reaction. Include the units. So rate equals to K concentration of H2O2 and concentration of iodide ion. I'm going to use experiment 1. So in experiment 1, the rate is 2.42 into 10 to the power minus 3. We need to find out the value of K. The concentration of H2O2 in experiment 1 is 0.045 and the concentration of iodide ion is basically 0.03. So the value of K from here is going to be 1.79. All right. Rate has a unit of mole per dm cube per second. It's given here equals to K. The unit of concentration is mole per dm cube. So it's going to be mole per dm cube for H2O2 and mole per dm cube for iodide ions. So it's mole per dm cube second inverse equals to K. जब मल्टीप्लाई हो तो पावर्स ऐड हो जाती हैं, सो आई नीड टू ऐड द पावर्स. So unit is going to be mole inverse 1 dm cube second inverse. Okay, mole inverse 1 dm cube second inverse. Let me calculate my value. Hold on. 0.045 into 0.03, 2.42 exponent minus 3 divided by answer is going to be 1.792. 1.7925. Okay, so I'm going to write 1.79. Okay. Okay, let's move on to the next page. The rate of thermal decomposition of azomethane is investigated. Results obtained as shown in the graph. The reaction is first order with respect to azomethane, sorry, azomethane. Yeah. Use figure 3.1 to calculate two half-lives to show that the reaction is first order. It must be the constant half-life. So 0.05 divided by 2, you will get 0.025. Okay. So roughly it is 60, 62. Yeah. So from here to here, it's going to be, I believe, roughly 60 seconds. And from 0.025 divided by 2, 0.0125. Hold on. 0.01 plus 2 exponent minus 3. 0.012 plus 2 exponent minus 3. 0.0125. 0.025 divided by 2. 0.0125. Yes, it has to be here. Okay. So from here to here, time is basically 120 seconds. This is the first half life, 60 seconds. And the second half life is basically 120 minus 60. So it's basically 60 seconds. Okay. So it's a constant half life. Hold on. From 0.05 mole per dm cube to 0.05, 0.025 mole per dm cube. First half life is 60 seconds. Okay. Then from 0.025 mole per dm cube to 0.0125 mole per dm cube, second half-life is again 60 seconds. Hence, constant half-life is observed. So reaction is first order. Okay. Use your answer to C1 to calculate the rate constant for the decomposition of azomethane. Since it is a first order reaction, the half-life for the first order reaction is basically 0.693 over K. We need to find out the value of K. So 0.693 divided by half-life. Half-life is 60 seconds. So 0.693 divided by 60 is going to be 0.01155. 0.01155 seconds. Okay. Describe the effect of increasing temperature on the rate constant and on the rate of reaction. That's technical. At high temperature, kinetic energy increases. So molecule move faster. If molecule move faster, so more molecules have energy equal to or greater than activation energy. All right. This is the first point. Second point, when temperature increases, rate constant increases. Okay, ये हम तो कहते हैं कि when temperature increases, rate constant increases, but why? What is the logic behind that? So this logic can be explained on the basis of Arrhenius equation. Let me give you a hint here so that you will get the idea what's the logic behind or what's the reason behind this answer. Arrhenius equation. Arrhenius equation is K equals to A E A E minus EA upon RT. That's the Arrhenius equation. You know, T is temperature, R is universal constant, A is activation energy, K is rate constant, and E is basically pre-exponential factor. So this is pre-exponential factor, okay? So when you increase the temperature, this entire thing will decreases, and this pre-exponential factor increases, and so rate constant increases. That's the whole concept behind this. So temperature increases, minus EA upon RT decreases, or it becomes less exothermic, or less exothermic, or less negative. Okay, then AE minus EA upon RT increases, and therefore rate constant increases. Okay. By the way, Arrhenius equation in some Arrhenius equation is also given and has been asked by the examiner in paper 5, and we have solved such concepts in paper 5 also via graph and all that, and gradient. So you can have an idea if you have practiced those questions, okay? But behind giving this statement, that is the whole reason. So you guys should know what's coming and what's the background for this answer. Okay, you should know what is the background behind this whole statement. I hope it makes sense to you. That's the end of this question. Define standard cell potential. Include a description of a standard condition. Okay, the standard cell potential. The potential difference between the two half cells measured at 298 Kelvin, 1 atmospheric pressure, under 1 mole per dm cube concentration of electrolyte. Okay. The Daniell cell is an electrochemical cell which converts chemical energy into electrical energy. And it consists of copper half cell electrode and zinc half cell electrode. That's what we have done in the class. Surprisingly, that's the exact same case we have done in the theory classes. Describe a label diagram of this electrochemical cell. Include all necessary substances and relevant piece of apparatus needed to measure the E0 cell. It is not necessary to state the conditions used. Okay. So obviously, we need to make a diagram here. So this is going to be your voltmeter, and this voltmeter is attached to copper and zinc half cell. Mhm. Okay. And both these half cells are connected via salt bridge. All right. Uh, okay. First of all, this is voltmeter. Okay. So this is voltmeter. It is also called high resistance voltmeter, which is also called potentiometer. This is copper electrode, and this half cell contain copper ions. So which means this copper ion must have a concentration of 1 mole per dm cube. It's not necessary to state the condition. Okay. So that's copper ions, also called copper sulfate. That's your salt bridge. That's your zinc electrode. All right. And that's zinc ions, which means the electrolyte has to be zinc ions or zinc sulfate. And obviously, the concentration of this electrolyte needs to be 1 mole per dm cube. So that's the diagram of the Daniell cell. By the way, there is as such no big difference between voltaic and Daniell cell, because voltaic and Daniell both are electrochemical cells and both have the same function, that they will turn chemical energy into electrical energy. Okay. So I've mentioned the substances, relevant pieces of apparatus to measure E node cell. Okay. That's the only thing. Let's move on to the next part. An electrochemical cell consists of zinc oxide and zinc electrode, and manganese 4 oxide and this electrode in alkaline electrolyte. The standard cell potential for this cell is plus 1.47. The half equation for each electrode of this cell is discharging is shown. Use this information to determine the change in oxidation state of manganese when cell is discharging. Cell is discharging means when cell is using or cell perform its function effectively, then it becomes start discharging. Manganese, MnO2. So manganese is X, oxygen has minus 2 into 2. Neutral air molecule equals to 0, then X equals to plus 4. So from plus 4, Mn2O3. Let's suppose manganese is 2x, oxygen has a charge of minus 2 into 3, because we have 3 oxygen atom. Whole charge equals to 0, then 2x equals to plus 6, then x equals to plus 3. Okay. So write the equation for the overall reaction that occurs when this cell is discharging. Since this is an oxidation reaction because electrons are lost, and since it is a reduction reaction because electron has been absorbed. So number of electrons are balanced. We need to cancel them out, and then we'll write the overall equation. Also, we need to cancel water. Also, we need to cancel hydroxide ions. So the remaining reactant is going to be zinc plus 2MnO2 arrow Mn2O3 plus zinc oxide. So that's the overall equation when the cell is discharging. So this is the overall equation when cell is discharging. For instance, examiner हमसे पूछते कि what is the overall equation when cell is recharged. So I need to flip this equation, okay, for recharging of the cell. The E naught for this electrode is minus 1.28. So this is the negative half cell because it has a negative SEP value. Uh, Calculate the standard electrode potential for this half cell. Okay, so by the way, we know E naught, right? We know E naught cell, so we need to find out the value of no, hold on. This is E naught left because it has a negative SEP value. This is E naught cell, which means this is going to be E naught right. So E naught cell equals to E naught right minus E naught left. E naught cell is plus 1.47 equals to E naught right. We need to find out. We need to get the value, and E naught left is minus 1.28. So it is plus 1.40 equals to E naught right plus 1.28. So the value of E naught right, which is basically E naught MnO2 slash M into O3, is basically 1.40 minus 1.28. So it's going to be how much? 0.19 volt. Okay. That's the end of this question. Let's move on to the next one. That's question. Oh my goodness. I forgot to. I forgot this. How? How is this possible? And why? Oh my goodness. Sorry about that, guys. State the charge carriers that transfer current through the solution. Through the solution, ions. In the wire, obviously electrons. I'm sorry about that, everyone. The standard electrode potential for zinc half cell is this. The standard electrode potential for this half cell is this. Water is added to this. The new concentration of zinc ions has to be this. Use the Nernst equation to calculate the electrode potential for zinc. That's an easy thing. First of all, zinc ions plus 2 electron, reversible sign zinc, and it has an E naught value of minus 0.76 volt. So that's the half equation for zinc electrode, okay? Use Nernst equation, E equals to E naught. E naught is minus 0.76 minus 0.059 divided by 2 because we have 2 electrons in the equation, log concentration of product, and product is zinc metal and metal is solid. So for all solid substances, we need to take the concentration 1, and the concentration of zinc ions is 0.25. So the value of E from here is going to be how much? Minus 0.778 volt. Okay, I hope I didn't miss anything. Okay, one, two, three, four. Yeah, let's move on to the question number 5. Next time I'll be more careful. Copper shows typical properties of transition elements, including behavior as a catalyst. Complete table 5.1 to show the total number of unpaired electrons in the 3d and 4s orbital of isolated gaseous copper atom and copper 2 ions. First of all, let me write down the electronic configuration of copper. So this is argon, indicate 18 electrons. We have, okay, hold on. Okay. So for copper metal, 4s contain 1 electron and 3d contain 10. If you remember, for copper 2 ions, 2 electron has been lost, which means 1 electron is lost from the 4s orbital and 1 electron is lost from the 3d orbital. So 3d orbital contain only 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, and this one is 9. So number of unpaired electrons in the 3d orbital is 0. 4s has 1 unpaired electron. Okay. In copper 2 ions, 3d has only 1 and 4s has 0. Okay. That's easy. The 3d orbital in an isolated copper 2 ions are degenerate. Degenerate means equal energy orbital. Complete the diagram to show the relative energies of the 3d orbital in an isolated copper 2 ions. And in copper 2 ions in a tetrahedral complex. So isolated copper 2 ions has a degenerate d orbital with equal energy. 1, 2, 3, 4, 5. Okay, this d orbital contain 9 electrons. 1, 2, 3, 4, 5, 6, 7, 8, and this one 9. In tetrahedral complex, T to G has higher energy and EG has lower energy. By the way, T to G has a group of 3 orbitals which contain dxy, dxz, and dyz, while EG contain a group of 2 orbitals which has dx squared dash y square and dz square. So this is basically T to G and this is basically EG. Okay. All right. I hope it makes sense to you. Why transition elements behaves as a catalyst? Because of the variable oxidation state. And also due to the availability of vacant orbitals, vacant d orbitals, which will serve as an active site. All right. Next, oh, let me check. Yeah. Cyanide is a monodentate ligand. I've told you in the class. Monodentate ligands are those which donates only one lone pair to the transition metal line. Figure 5.2 shows information about two complex ions that contain only cyanide ions as ligands. When we have silver ion and when we have cyanide ions, the the formula of complex ion would be AgCN. Since coordination number is 2, which means two dative bonds are formed, so I'm going to use two cyanide ligands. And to get the +1 oxidation state of silver ion, I need to mention -1 here, okay? So charge is basically -1. I cannot write -1 like this because ये गलत हो जाएगा. जब एग्जामिनर ने चार्ज पहले लिखा है, साइन बाद में लिखा है, तो मैं यहाँ पर भी पहले नंबर लिखूंगा, बाद में साइन लिखूंगा. अगर किसी बच्चे ने 1 माइनस इस तरह से, सॉरी, -1 करके लिखा, सो ऑब्वियसली मार्क्स नहीं मिलेंगे उसको. ठीक है. Fe2 प्लस coordination number, formula of complex ion. So in Fe2 plus, we can attach 6 cyanide ions. On the basis of that, the formula is going to be FeCN6. And to get the 2 plus oxidation state of iron, I need to put 4 minus charge here. So 4 minus charge agar hai aapke paas, so obviously you need to mention 6 cyanide ligands so that you will get 2 plus charge, or you will get the oxidation state of 2 plus charge of iron. Okay, I hope it makes sense to you. Since it is 4 minus charge and it has an oxidation state of 2 plus, which means I need to use 6 ligands, and therefore the coordination number is going to be 6. That's what I was trying to explain you. Okay, the complex ion, this displays geometrical cis trans isomerism. Why? Because it shows Ml2 X2 situation, because it has two similar ligands, two different ligands, which means it is a situation of Ml2X2, and Ml2X2 situation shows cis trans isomerism. Draw the structure of trans. Oh, draw the structure of trans, stated shape, and the BBr bond angle. Okay, trans. Okay, so it's basically gold AU. The shape is going to be square planar. Whenever we have Ml2X2 situation, geometry is going to be, or shape is going to be a square planar. Okay, and trans means that these bromine atoms needs to attach opposite to each other. Okay, and this is going to be your cyanide. And we need to mention negative charge because examiner ने यहाँ negative charge mention किया हुआ है. Okay, the bond angle of this is basically, examiner is looking for this angle, and this angle is going to be 180 degree. We have discussed cisplatin, which was Ml2X2 case, and in that case मैंने दो एंगल्स बताए थे आपको 90 डिग्री, जो कि एक्चुअली यहां पर होगा इन दोनों लाइगेंड्स के दरमियान, बट इस तरह से 180 डिग्री होगा. ओके, so examiner is looking for this, which means I have to give 180 degree. Okay. Oh my goodness. An impure sample of vanadium 5 compound of mass 0.25 gram dissolved in aqueous acid. This solution contained VO3 negative ions. Excess of zinc is added to this solution. All the VO3 negative ions reduced to V2 plus ions. That's called successive reduction process. And I've given you the information, the concept about this successive reduction. I've given you two different scenarios in electrochemistry: successive oxidation and successive reduction. So it is an example of successive reduction, in which vanadium 5 will turn to vanadium 4, vanadium 4 will turn to vanadium 3, and then vanadium 3 will turn to vanadium 2 ions. Okay. The unreacted zinc is removed. Unreacted zinc is removed through filtration, obviously. And the resulting solution is titrated with acidified magnate 7 ions. Magnate 7 ions is basically an oxidizing agent. The end point is reached when this volume and concentration of magnate 7 ion is added. A redox reaction takes place and all the V2 plus reacts, forming VO3 plus ions. Okay. So technically, magnate 7 ions, being an oxidizing agent, oxidizes V2 plus to V3 plus, then V3 plus to V4 plus, and then V4 plus to VO3 minus. And that's successive oxidation. Okay. That's very critical, both simultaneously oxidation and reduction. Calculate the percentage, my goodness, the percentage by mass of vanadium in this impure sample. Okay, show your working. Okay, first of all, get the moles of magnate 7 ions by using the volume and concentration. So it's going to be 1.6875 into 10 to the power minus 3 moles. Okay. According to the equation, magnate 7 ions and V2 plus ions has a molar ratio 3:5. When we have 1.6875 into 10 to the power minus 3 moles, so the moles of V2 plus is going to be into 5 divided by 3, 2.8125 into 10 to the power minus 3 moles. Okay. The moles of V2 plus is known now. Using this moles, I can find the mass of vanadium. So moles of vanadium is 2.8125 into 10 to the power minus 3. And the relative atomic mass of vanadium is basically 50.9. It's given in the periodic table. It's going to be 0.413 gram. Okay. Now we need to find the percentage by mass of vanadium. So mass of vanadium is 0.143 divided by mass of sample, which is 0.250 into 100 divided by 0.25 into 100. So it's going to be 57.2 0.2625%. So it's basically 57.3%. Okay. Complete the equation for the reaction between acidified vanadium 5 ions and zinc metal. Okay. So how many oxygen atoms we have? 3. To balance 3 oxygen atom, I will use 3 moles of water. How many hydrogen atoms here? 6. So I'm going to write 6 hydrogen atoms here. Whew. But charge is not balanced. We have 4 plus and we have 5 plus. So if to balance the charge, if I use 2 vanadium here, so I'm going to put 2 here also. So how many oxygen atoms now? 2 times 3, 6. So instead of using 6 oxygen, how many hydrogen atoms now? 12. Instead of using this, I'm going to write 12 hydrogen ions. Let me check the charge now. This is 2 minus and this is 12 plus. It becomes 10 plus. Over here 4 plus. Over here 2 plus. Oh, it's not balanced. Wait, hold on. How much charge we have? This is 10 plus. तो मुझे यहाँ पर भी 10 प्लस चार्ज चाहिए. इधर कितना है? 4 प्लस. तो 10 प्लस करने के लिए मुझे यहाँ पर 6 प्लस चाहिए. और 6 प्लस उस वक्त आएगा जब मैं यहाँ पर 3 रखूंगा, तो मैं ऑब्वियसली यहाँ भी 3 रखूंगा. So I'm gonna put 3 here and 3 here. Okay. I hope it makes sense to you. Oh, that's the end of this equation. Okay. That's the end of this question also. Let's move on to the next one. Thin layer and gas liquid chromatography can be used to separate mixture into their individual components. Define RF value, retention factor. So it is a ratio. So it is the ratio of the distance traveled by solute to the distance traveled by solvent. And the next is retention time. The time taken of a solute to pass through the column is called retention time. That is the time taken of a solute to pass through the column. That is from the point of injection to the point of detection. Okay. Each chromatography makes use of station phase and mobile phase. In thin layer chromatography, the mobile phase is going to be any liquid. It could be ethanol or it could be water. And both ethanol and water are polar solvents. So you can write polar solvent. In gas liquid chromatography, the stationary phase is basically uh, porous diatomaceous earth having a high boiling liquid like waxy polymer. That's what we have done in the class. So high boiling liquid with porous diatomaceous earth. That diatomaceous earth is basically an inert material. Okay. A mixture of two substances, A and B, is analyzed by thin layer chromatography. RF value of substance A is larger than that of substance B. Explain why A has a larger RF value. If A has a larger RF value, then means substance A covers the most distance. If substance A covers the most distance, which means it is less polar and it has a strong affinity with the mobile phase, or you can say that it has a less affinity with the stationary phase. So substance A is less polar so it has a strong affinity with the mobile phase and less affinity with the stationary phase. Stationary phase is made up of silica gel, and the surface of silica gel is extremely polar because of the presence of OH group. Even you can check in my lecture also. Okay. So if substance A is less polar, then it means it will show a less tendency with the surface of a stationary phase, and therefore it will dissolve more in the mobile phase, and so it will cover the most distance. If it will cover the most distance, obviously the retention factor value is going to be larger, or it's going to be more. I hope it makes sense to you. Okay. But for this specific part, I need you to go through the lecture again so that you can have an idea your thin layer chromatography may how separation works, okay, and on what basis. So you will get the idea from that particular topic. So that's C B part. Next C. Okay, the two isomeric compound Y and Z are analyzed by proton spectroscopy. Okay, complete the table 6.2 to predict the number of peaks in proton NMR. Okay, okay, I'm gonna write it. First of all, let me write this structure in this way: CH3, CO, CH2, CH2, CO, and then CH3. Now, see, guys, these six hydrogens have same chemical environment because they are attached with the same function group. Okay, which means these six hydrogen have same chemical environment. So when I apply n+1 rule on this carbon, so obviously the neighboring carbon atom has no hydrogen, which is why it's going to be 0 + 1. You will get 1 and you will get the singlet. Okay. And since it is CH3 attached to carbonyl, so the chemical shift of this particular functional group is going to be 2.2 to 3.0 delta. I hope it makes sense to you. Again, let me show you one more thing. These 4 protons have same chemical environment because जितने डिस्टेंस से ये CH2 इस ग्रुप से अटैच है उतने ही डिस्टेंस से ये CH2 भी इसी ग्रुप से अटैच है. So these 4 protons have same chemical environment. So now CH2 के नेबर में जो कार्बन है उसके पास कोई हाइड्रोजन नहीं है, which is why it's going to be 0 plus 1, 1. You will get singlet. And again, it is CH2 attached to carbonyl, and therefore I can say the chemical shift value is going to be 2.2 delta to 3.0 delta. Okay, जाहिर सी बात है रेंज सेम है लेकिन केमिकल शिफ्ट की वैल्यू सेम नहीं हो सकती बिकॉज इसका एनवायरनमेंट इसके हिसाब से डिफरेंट है और इसका एनवायरनमेंट इस हिसाब से डिफरेंट है. ओके, so technically we will get only 2 chemical environments, so number of peaks would be 2. Let me talk about Z. Z is CH3, CH2, CO, CO, CH2 and CH3. Okay, number 1. These 6 protons have same chemical environment because they are attached with the same distance of these functional groups, right? Now these 6 protons have two neighbor hydrogen atoms. So obviously these 6 protons will give you triplet. All right. Again, these 4 hydrogen atoms have same chemical environment because same distance के साथ carbonyl group से attach हैं. On the basis of that, अगर मैं n+1 rule apply करता हूँ, so obviously 4 protons के neighbor में 3 hydrogen atoms हैं. 3 plus 1 becomes 4, so you will get quadrate. So technically, number of peaks again 2. The one is triplet and the other one is quadrate. Name all the different splitting patterns. All the different splitting patterns observed in proton NMR. So it's singlet. Okay. In fact, 2 singlets. And in Z, one is triplet. And one is quadrate. That's the end of this question also. Let's move on to the next question. State the relative acidities of bromoethanic acid, chloroethanic acid, and ethanic acid and ethanol. Well, the more electronegative element is attached to carboxylic acid, the easier the removal of hydrogen ion, the stronger the acid, which means chloroethanic acid is the most acidic one. Okay. Then bromoethanic acid is lower than chloro. Then ethanic acid is lower than bromo but higher than ethanol. And ethanol is technically neutral. It is the most least acidic one. Okay. Let me explain because examiner is looking for the explanation also. Now chlorine and bromine both are more electronegative elements. Both are electron withdrawing groups. Both chlorine and bromine are more electronegative elements. So they have negative inductive effect. This weakens the OH bond, hence ionization is easier. Also stabilizes anion. Next, electron donating alkyl group is attached to carboxylic acid that has a positive inductive effect that cannot weaken the OH bond, hence ionization is not easier. Also, it destabilizes the anion. In ethanoic acid, CH3 is an electron donating group with a positive inductive effect. Due to which ionization is not easier and destabilizes the anion. Okay. Last, in ethanol, alkyl group has positive inductive effect. So it strengthens the OH bond, hence ionization becomes difficult. Uh, this area I have discussed with you in theory classes in such a detail that you should have an idea how to go about such um, explanations. But let me show you. This is ethanoic acid. Okay. It ionizes into its anion and hydrogen ion. Okay. Now this alkyl group has a positive inductive effect. So it neutralizes the partial positive charge of carbonyl carbon, which is why this carbon cannot pull the electron from oxygen atom. and therefore oxygen cannot pull the electrons from hydrogen. So this ionization of hydrogen is not possible conveniently. Also, why the anion destabilizes? See, this is CH3, CO, O negative. There must be a resonance process, right? Okay. होता क्या है कि ये नेगेटिव चार्ज यहाँ पर बॉन्ड बनाएगा. At the same time, pi bond shifts onto this oxygen atom, and as a result, this oxygen becomes negatively charged, and then we have double bond here. Now, फिर क्या होगा कि ये नेगेटिव चार्ज यहाँ पर आएगा और ये pi bond इस ऑक्सीजन एटम पे शिफ्ट होगा. तो इसका मतलब इन दोनों स्ट्रक्चर्स के दरमियान एक रेजोनेंस का प्रोसेस होगा. ये रेजोनेंस होता रहता है, एनाइन स्टेबल होता है. बट जैसे ही ये CH3 आकर अटैच होता है, तो इस CH3 का पॉजिटिव इंडक्टिव इफेक्ट होता है. It has a positive inductive effect. It donates electron. जैसे ही ये इलेक्ट्रॉन डोनेट करेगा इस कार्बोनाइल कार्बन को, so obviously the charge of carbonyl carbon is neutralized by this positive inductive effect of alkyl group. As a result, ये जो रेजोनेंस ट्रिगर हो रही थी ये नहीं हो सकेगी. तो जब रेजोनेंस ट्रिगर नहीं होगी तो जाहिर सी बात है एनाइन भी स्टेबल नहीं रहेगा. आई होप इट मेक्स सेंस टू यू. आई होप मैंने यहाँ पर क्या लिखा है इसके लिए. ठीक है. And that's what we have done in the class. Okay, let's move on to the next thing. Figure 7 point shows the reaction of methyl benzene and ethane dioic acid with KMnO4, the major carbon containing products for each of these reactions. Since it is an oxidizing agent, it oxidizes methyl into carboxylic acid, and since we have an alkaline medium, so that carboxylic acid will turn to a salt. So I'm going to write salt straight away. Okay. So first, this CH3 will turn to COOH. So it's going to be benzoic acid, but because of this medium, it will turn to a salt. So I'm going to write salt, okay? Now, ethane dioic acid is a reducing agent. We have done that in electrochemistry also, in A1 chemistry also. This is oxidizing agent. So whenever KMnO4 is treated with ethane dioic acid, carbon dioxide gas is given off, and examiner is looking for the carbon containing products. So I'm going to write carbon dioxide, okay? By the way, we have done this balanced chemical equation both in A2 and in AS, okay? So you must have an idea about that. Otherwise, it will take a long time to explain such scenarios. Hold on, let me explain it. This is H2, C2O4. It is converting into carbon dioxide. How many hydrogen atoms here? Carbon atoms here, 2. Put 2 here. How many oxygen atoms here? 4. So this is 4 oxygen atom. How many hydrogen atoms here? 2. So I will put 2 hydrogen ions here. So to balance the equation, I need to put 2 electrons so that charge 0 हो जाए. यहाँ पर भी charge 0 है. And magnate 7 ions is basically converting into Mn2 plus. According to ion electron rule, we have 4 oxygen atoms. So I'm going to write 4 water molecules. We have 8 hydrogen atoms. So we have 8 hydrogen ions. To balance the charge, I'm going to put 5 electrons here. We need to balance the number of electrons. So मैं इसको 5 से multiply करूंगा और मैं इसको 2 से multiply करूंगा. As soon as the number of electrons are balanced, we need to cancel them out. We need to cancel hydrogen ions also. And we need to write the remaining equation. So in the remaining equation, let me write down 2 MnO4 negative, 8 hydrogen ions left. Sorry, 6 hydrogen ions left. 16 and 10, 6 left, plus 5 H2 C2O4 arrow 10 CO2 plus 2 Mn2 plus 8H2O. Okay, so that's the balanced chemical equation. C, the carbon containing product is carbon dioxide, which is why मैंने यहाँ पे लिखा है. So you should have an idea कि भाई किस तरह से इनको solve करते हैं. So you need to revise ion electron equations from the A1 chemistry redox का chapter, and we have done chemistry of carboxylic acid in A2. उसमें भी मैंने ये कराया हुआ है आपको. Let's move on to the next page. Let me check with question तो नहीं रह गया. Okay. Polyamide X can be synthesized from ethane dioic acid and benzene 1,4-diamine. Okay, draw the repeating unit of the polyamide X in the box. The new functional group form should be shown displayed. So whenever diamine react with dicarboxylic acid, always an amide is formed. So the structure of polyamide is going to be like this. NH, benzene ring. This is NH. This is CO. And ethane dioic acid. This is CO. This is NH. This is benzene ring. This is NH. And that is the bond continuation. Okay. So the functional group needs to be shown in a displayed pattern. Okay. And what is the repeating unit? So this is going to be the repeating unit from this to this. This is the one repeating unit. Okay. This is the repeating unit, guys. So आप सिर्फ इतना स्ट्रक्चर भी लिख के दे सकते हो एग्जामिनर को, वो भी एक्सेप्टेबल होगा. I hope it makes sense to you कि मैंने किस तरह से बनाया. By the way, we have done this equation in A2, right? So you guys must have an idea कि भाई ये किस तरह से करते हैं. Benzene 1,4-diamine can form by reduction of this. Complete the equation for this reaction. Okay. 1,4-dinitrobenzene. My goodness. 1,4-dinitrobenzene. So this is the structure of 1,4-dinitrobenzene. We have 6 carbon atoms in this. We have 1, 2, 3, 4 hydrogen atoms in this. We have 2 nitrogen atoms. We have 4 oxygen atoms in this. When they will react together, oh, that means examiner is looking for the structure, right? So मैं इसको molecular formula नहीं लिख सकता हूँ. I have to write this here as it is. But मैं अपनी अपनी तसल्ली के लिए लिख लेता हूँ. C6H4N2O4. मैं ये इसलिए लिख रहा हूँ ताकि मुझे बैलेंसिंग में आसानी हो. This is C6 1 2 3 4 5 6 7 8 2 nitrogen. There is no oxygen. Okay, so how many oxygen atoms here? 4. 4 oxygen will turn to 4 water molecule. How many hydrogen atoms here? 8, 10 and 12. So I will put 12 hydrogen atoms here. Okay, so that's the balanced chemical equation, everyone. I hope you get the point. वैसे मैंने इसका कॉन्सेप्ट भी सिखाया हुआ है आपको A2 के अंदर, आपको पता होना चाहिए. Let me repeat. There are 4 oxygen atoms here. When these 4 oxygen atoms combine with hydrogen, you will get water. And obviously we have 4 oxygen. So to balance oxygen, I will put 4 here. Now total hydrogen atoms here is 12. Oh, sorry, 8. 8 plus 2, 10. 10 plus 2, 12. So I'll put 12 here. So that's the balanced chemical equation. Okay. Okay. ओके, इसके अलावा मुझे कुछ, आई मीन दैट्स द ओनली पॉसिबिलिटी. पार्ट डी. Figure 7.2 shows two-step synthesis of the azo compound W. It is benzene diazonium chloride. So this will turn to diazonium group. This will turn to diazonium group. Okay. So it will turn to N triple bond N. This is plus. This is Cl minus. This is N triple bond N plus, and this is Cl minus. So we have two chloride ions balanced. We have four nitrogen atoms balanced. We have six carbon balanced. We have four hydrogen atoms balanced. Okay. When this compound is treated with phenol in the presence of NOH, you will get an azodie. And obviously, azodie यहाँ से भी बनेगी, azodie यहाँ से भी बनेगी, which means 2 moles of phenol needs to be used in this reaction. So how can I write two reactions? Okay. Let me draw the structure. This is N double bond N. And obviously this nitrogen needs to attach with the phenol. Okay. ये भी N double bond N में होगा और ये भी अटैच होगा फिनोल के साथ. एंड दैट्स योर एजोडाइड. और मैंने जज कैसे किया? मैंने आपको बताया था कि OH जिस कार्बन के साथ अटैच होता है इसकी बिल्कुल जो ऑपोजिट कार्बन होती है वो इस नाइट्रोजन के साथ बॉन्डिंग करती है. सो मैंने वही चीज अडॉप्ट की है. OH जिस कार्बन के साथ अटैच है एग्जैक्टली उसके बिल्कुल जो ऑपोजिट कार्बन है उसकी बॉन्डिंग मैंने नाइट्रोजन के साथ करवाई है. सेम हियर. ओके. That's tricky. Suggest the structure for, okay, we have done the structure. Give the reagents and conditions for step 1. So to convert NH2 into diazonium chloride, we need reagents. Reagents, that means I will use sodium nitrite and HCl as a reagent. And condition is basically below 10 degrees Celsius temperature. Okay. All right. That's the end of this question. Let's move on to the next one. Question number 8. In this electrophilic substitution of arenes, different substituents can direct different ring positions. And that's called orientation of benzene, which we have discussed in such a detail ताकि आप ये questions apply कर सके. Describe the directing effect of NO2 group. Explain your answer. Well, NO2 group is a matter directing group. So it directs the electrophile towards meta position. That is third and fifth. Okay. The nitration of arenes uses a mixture of concentrated nitric acid and concentrated sulfuric acid to generate electrophile. Write an equation for the formation of this. It's easy. 2 moles of sulfuric acid is reacting with 1 mole of nitric acid, converting into 2 HSO4 negative plus H3O positive plus NO2 positive. You can write this equation for 1 mole also, okay? That's not a problem. Carbon-carbon bond formation is an important reaction in organic synthesis. Figure 8.1 shows synthesis of compound Q from benzene in two reactions. So, oh my goodness. First of all, we have an acyl group and then we have an alkyl group. So, compound undergoes both acylation and alkylation. And since acyl is a matter directing group, so the incoming electrophile needs to attach on third and fifth position. Check this alkyl group attached to the third position, which means ये जो आपका अल्काइल ग्रुप है ये इस ग्रुप के इन्फ्लुएंस के थ्रू आकर अटैच होगा या एसाइल ग्रुप के इन्फ्लुएंस के थ्रू आकर अटैच होगा, which means first of all we need to go for acylation. So I'm going to write this. Okay, that's tricky, guys. Let me repeat. Let me give you an explanation again. This is an acyl group, which is a meta-directing group, and it directs the electrophile towards third and fifth carbon, which means alkyl groups, which is attached to the benzene ring, needs to attach either with the third carbon or fifth carbon. When we count the number of carbon atom, it is first, it is second, it is third, which means it is attached to the right position, that is meta position. इसका मतलब सबसे पहले जो है वो असाइल ग्रुप इंट्रोड्यूस करूंगा मैं एंड देन उसके बाद अल्काइलेशन होगी. ओके, draw the structure of compound P. We have done that. Suggest reagent and conditions for reaction 1. So ethanol chloride is the reagent used in the presence of AlCl3 as a catalyst. And in reaction 2, we need to attach alkyl group, and for this I'm going to use CH3 CH Cl CH3 in the presence of AlCl3, which acting as a catalyst. Okay, so इसको देख के मैंने डिसाइड किया कि this sort of alkyl halide needs to be used, और इस क्लोरीन की जगह जरूरी नहीं है आप क्लोरीन लें, it could be bromine, it could be iodine, that's totally up to you. Okay, and obviously अगर आप यहाँ ब्रोमीन यूज करेंगे तो it has to be AlBr3, अगर आप यहाँ iodine यूज करेंगे it has to be AlI3. so ये भी आपने ध्यान में रखना है अगर आप इस तरह से चीजों को लेके चल रहे हैं. Okay, next, separate samples of bromobenzene and this compound are added to warm silver nitrate. State the expected observation, if any, explain your answer. With bromobenzene and silver nitrate, no visible reaction. No reaction, no change. Because aromatic alkyl halides or aromatic alkenes or aromatic alkyl halides or aromatic aryl halides cannot react with any reagent because of the strong carbon chlorine or carbon halogen bond. On the other hand, this silver nitrate reacts with bromine, and obviously you will get creamy precipitates. Okay. In bromobenzene, lone pair of bromine is delocalized with a pi bond of benzene and this makes carbon bromine bond stable. In C6H5 CH2Br, Carbon bromine bond is polar. Which can undergoes reaction easily. Okay. Acyl bromide reacts with water. Okay. The mechanism of this reaction is similar to the reaction of water with acyl chloride. Name the mechanism. Addition, elimination. Complete the mechanism. Include all relevant lone pairs. So this oxygen has a lone pair. Charges and dipoles. Oxygen has slight negative charge and carbon has slight positive charge. It reacts with this carbonyl carbon and forms a dative bond. At the same time, oxygen pi bond shifts towards oxygen atom. So it's going to be R, C, O. This becomes negative. This is Br. This is oxygen. This oxygen has two hydrogen atoms. And this oxygen has three bonds, so it has a positive charge. Okay. Now, this negative charge makes a double bond here. At the same time, bromine removes in the form of bromide ions. This bromide ions reacts with hydrogen ions to give HBr, and this shifts towards oxygen atom. Okay. I hope it makes sense to you. ये नेगेटिव चार्ज यहाँ पर बॉन्ड बनाएगा एट द सेम टाइम टू सेटिस्फाई द नंबर ऑफ बॉन्ड्स ऑफ कार्बन. Bromine removes in the form of bromide ions. Bromide ions combined with hydrogen ion to give HBr. All right. And the electron of hydrogen goes towards oxygen so that उसका ये positive charge खत्म हो जाए. So oxygen pulls the electrons from hydrogen to eliminate its positive charge. Bromide reacts with hydrogen ion to give HBr, and this lone pair forms a bond again between carbon and oxygen to form a product. That's tricky. That's what we have done in the class. I'm so happy. That's the end of this question. Oh my goodness, that's a huge paper. Oh, explain why amides are much weaker base than amines. Lone pair of nitrogen in amides lone pair of nitrogen in amide is delocalized with a pi bond of oxygen. So lone pair of nitrogen is not easily available for protonation, which means it is a weaker base. Okay. So cannot accept proton easily. Okay, now this is amide, it is converting into amine, and for that I'm going to use lithium aluminum hydride. By the way, amines are formed when nitriles undergoes reduction with hydrogen in the presence of nickel catalyst, so M is going to be nitrile. When alkyl halide reacts with ammonia, an amine is formed, which means N is going to be alkyl halide. So suggest the structure for compound M and N. Okay, let me suggest the structure. This is benzene ring, CH2. This is CH2, and this is CN. Okay, so this CH2 will remain as it is. This C will turn to CH2, and this N will turn to NH2. Okay, so I hope it makes sense to you. N, let me draw N. CH2, CH2, and then Cl. So अब Cl लिखो, CBr लिखो, Ci लिखो, it's totally up to you. Okay, so this CH2 will remain as it is. This CH2 will remain as it is, and instead of chlorine, NH2 will come. Okay, here we have CH2, this is CH2. This carbon will turn to CH2, this nitrogen will turn to NH2. I hope it makes sense to you. Give the reagent conditions for its reaction 1. It's lithium aluminum hydride. Okay, next. My goodness, 9.2 shows compound H, which is useful starting material in organic synthesis. H contain an alkene and an amine functional group. That's true. This is alkene, this is amine. This is basically ketone also. Other functional group in H, ketone. Classification of amine. If one hydrogen is attached to nitrogen, it's going to be secondary amine. Ozonolysis is a very, very typical sort of reaction in alkene. आपके सिलेबस में नहीं है A1 में, लेकिन एग्जामिनर यहाँ क्वेश्चन में पूछ रहे हैं वो आपसे, तो इसका मतलब आपको वो सपोर्ट करेंगे और फिर आपसे कुछ ना कुछ पूछेंगे इसमें से, because it's not the part of your A1 and A2 syllabus, and he's asking the question, which means we need to give some sort of importance to this ozonolysis reaction. So carbon, double bond carbon in alkene using ozone as shown in the figure. So when ozone reacts with alkene, it will turn to ketone. Okay, because ये reaction exactly hot concentrated KMnO4 जैसा हो रहा है. When we have double bonded carbon, it will turn to ketone. When we have double bonded carbon, it will turn to ketone. So somewhat वही reaction है, but एक different perspective से होता ही है हमेशा. इसको understand करने की जरूरत है. उन्होंने कहा है shows the first step in this reaction which involves the formation of ozonide intermediate. तो वो कह रहे हैं कि ये दोनों reaction करें और ये बनाओ. तो वो कह रहे हैं draw 3 curly arrows. ओके, यहाँ उन्होंने क्या दिया, draw 3 curly arrows to complete the mechanism of this step. 3 curly arrows. Okay. Let me show you one thing. This lone pair reacts with this. Hold on. This lone pair reacts with this. This lone pair with this carbon atom. At the same time, the pi bond of reacts with this oxygen, and to eliminate the positive charge of oxygen, bond shifts onto this oxygen atom. I hope it makes sense to you. I hope it makes sense to you. It's a concerted mechanism. ये इससे रिएक्शन करेगा, बॉन्ड बनाएगा कार्बन से. pi bond of oxygen इस ऑक्सीजन से बॉन्ड बनाएगा. ये बनाया हुआ सही है. दोबारा से देखिए, ये नेगेटिव चार्ज इससे बॉन्ड बनाएगा, ये बना हुआ कार्बन के साथ. ये pi bond of alkene reacts with this oxygen atom, ये बनाया हुआ, and the pi bond shift towards oxygen to eliminate the positive charge of oxygen, ये बना हुआ, neutral हो गया ये, तो 3 bonds हो गए, okay, 3 arrows हो गए. I hope it makes sense to you. L is formed from alkene. Oh my goodness, L is formed from alkene by similar reaction to that shown in figure 9.3 suggests the structure of K. So we are getting two different ketones. I mean, we are getting ketones. So from alkene, we are getting ketones. Okay. Guys, this is CH3. Okay. This is ketone, which means it has to be double bonded C. Okay. Then this is CH2, 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 3 CH2, 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 3 CH2. This is again carbonyl group. So it must has double bonded C, and this is CH2, CH3. And that's the structure of alkene K. I hope मैंने सही बनाया हूँ. But ये तरीका है काम करने. But that's a very, very good question. Amazing, amazing. From my perspective, it's one of the best question and best part I've ever solved in A2 chemistry, because that requires a lot of analytical skills and thinking skills, and that requires a very strong theoretical concepts also. Oh, okay. So let me write down this structure here. Okay, that's the answer. Well, that's the end of this paper, guys. Thank you very much.